So what is an arc? We've talked about this. This is just a review. What is an arc, Jackson?
Oh, it's something that is less. You're still wrong.
Okay, here we go. Something that's what?
It has to be 179 degrees or less up like a circle.
Okay.
It's almost like a semicircle, but it's not.
Okay. So I think you're referring to maybe a minor arc.
Yes.
Okay, so we had minor arcs and we had major arcs. So are we going to assign a number? But when you said after that, of what kind of shape? Of a circle. So is it a part or a portion of a circle? I'm actually going to go even farther and say part of the circle's circumference. So it's a part of the outside rim of the circle. Okay? And then we specified less than 180 degrees was a minor arc, more than 180 degrees was a major arc. We said some of that. So if we draw a circle here, over to the side for an example, if I have other colors than purple, AB. Is that an arc? Can we say it? How do we say that? Arc AB. You write it with a little arc over the top, correct? Arc AB. If I were to connect the radii that go, let's say, from the center to A and to B, is there a central angle? What is the central angle? Definition, and what is the example? What is it? Say that again. Angle AOB is the central angle. Okay, but what is a central angle? The angle in the middle, it goes to maybe we might say the center. The middle of the circle is really called the center, right? Yes. And what is that at the center of the circle? What part of that angle? Two radii that connect at the center. So the vertex is at the center of the circle. Central angle is simply an angle whose vertex is at the center of the circle. I need to say of the circle. Okay. What if I say the measure of the central angle, AOB, is 60 degrees? Okay. If I say that, can I ask you a question? What's the measure of the arc, AB? Is it simply 60 degrees? Yes, it is. The measure of the arc is the exact same. It's always equal to the central angle. Okay? The measure of the arc. Have we yet talked about what an arc length is for our title? No, this is review. We've all seen this before. But let's tie it into, what if I want to know the length, the actual length of the arc? What's something I might need to know? Do we need to know the circumference of the circle? To know the circumference of the circle, what else do we need to know in this problem? The diameter or the radius. So if I give you the radius, because I've only drawn a radius, we're going to start with 5 inches. Okay? If I give you the radius is 5 inches, You've got a central angle. Lucas has said we need something about the circumference. Okay? But if you want the length of an arc, write those two words together. Length of an arc, or we're going to say the arc length. They're going to phrase it both ways. Okay, the length of an arc. You might say arc length. Okay? If they ask you for the arc length, or the length of the arc, it's not going to be the same as the measure. The measure is the degrees. Okay? It's going to ask you for an actual length. Somebody said it's the circumference, but is it the whole circumference? No, what is it? Is it just part of it? So how do we take a part? Okay, going back a long time. What is a part of something? What is a part of something? A piece taken out of the whole. Okay, yes. What else?
It's not all.
It's not all
Yeah, I mean, it's not all of it.
of it. In math, we might say it's a fraction of the whole thing, right? So do we have a fraction of our whole? What fraction do we have?
A 6.
Okay, how did you get that? Let's walk backwards.
360 divided by 60 equals
6. So I agree 360, but not quite that way.
What?
You said 360 divided by 60, and I said it's 6. You can't have 6 somethings when you don't even have a whole something. What? What fraction do you have?
1/6.
1/6. So do you have 60 divided by 360?
300. I don't know.
Do you have an angle? 60
60
degrees.
divided by 360.
Not the other way around. Those are two different answers. Okay, does that make sense? You have a measure. I'm going to write a formula first. Then we're going to plug in numbers. So you have a fraction. In this case, this example is going to be 60 degrees over 360 degrees. Why did we use those numbers? We have 60 degrees that was given to us. Out of what's the whole circle? 360 degrees. So we have this fraction of the circumference. What does of mean in math?
Divide. Multiply.
Multiply times of. What's the circumference of this circle? What is circumference not of this circle necessarily yet?
31.4.
What is 3.14? That means nothing to me.
Pi.
30. No, I said 31.4.
Oh.
I said no.
2 times pi times the radius.
2 times pi times the radius. No, it's not. It's pi d. Okay, 2 times the radius is the diameter. Okay, area is squared. Okay, so 2 times what's circumference? If you want to put 2 pi r, that's okay.
Wait, what? How is that?
What's 2 times the radius?
Oh, I get it.
Is it the diameter? Okay, I'm going to ask you, please, don't use 3.14. Don't.
Punch in the
It's
numbers.
pi. Okay, it's pi.
Oh, so that's how I'm wrong.
That's how you're wrong.
Oh.
Don't.
So technically my math is right. In number
I
form.
think you're saying no.
Yes, but okay.
Don't use 3.14.
Okay.
Don't use 3.14 unless they ask you specifically. Use 3.14 for pi. Just don't.
What if
Okay.
you do it on the calculator?
So even if it says something.
You leave it in terms of pi. That's what we're going to do today. We're going to leave it in terms of pi. It's so much more wonderful.
Then you don't know.
It is the exact answer. Okay? Leaving it in terms of pi is an exact answer. Okay? It's very good. Okay? Leave it. Here's your formula for arc length. It's a fraction of the circle. Let's put an extra line there. Fraction of the circle times the circumference. Maybe I need to box that. Put a box around that. That's a good one to know. So this example that we're given for the arc length of AB equals 60 degrees over 360 degrees times what? Jackson said it earlier in not full thing. Okay? I don't want you to pick up your calculator at this time. Yes, sir. Do we need to reduce? Is this my final answer?
You can do 1 5.
No. Say it again.
1 6.
So 60 divided by 36 is 1/6. So what's 1/6 of 10 pi? Let's multiply. What do you get?
10 pi over 6.
10 pi over 6. Should we leave it like that?
Yes.
What?
No,
No, it will be
Oh my gosh.
5 over 3.
It'll be 5 over
Why
3.
would you not do that if
5
you're leaving
pi.
pi?
5 over 3 times pi.
5 pi over 3. Are we done?
Yes.
So close.
No.
Oh, I told you.
What is length?
Inches.
Inches.
What is length in inches this time?
Each word.
Don't forget your units. 5 pi over 3 is an excellent, wonderful answer. Okay, I would rather have this answer than 12 decimal places. They'll only give you 10. Never mind, 10 decimal places. Okay, so let's do another one. What happens if? Actually, they just write it out for you. Find the length of an arc intersected. No. Find the length of an arc with a measure of 75 degrees in a circle with a radius of 4 feet. So they don't draw it out for you. They just say it. Bless you. Bless you.
What was the?
Find the length of an arc with a measure of 75 degrees in a circle with a radius of 4 feet. So I draw it every time. Okay, that's 4 feet. That angle is 75 degrees. What is the length of an arc?
75 degrees.
No, that's the measure of the arc is
Oh,
75
the length
degrees.
would be 75 divided by 360. That would
No.
be the fraction, and then you do that times the circumference.
75 degrees over 360 degrees times what? 8 pi.
Yeah.
Now the thing is, I still want it in terms of pi. So if you're putting stuff in your calculator, everybody got a calculator? Please get your calculators out.
Alright, let's run it home.
Oh,
Borrow one from right there.
What?
All right.
Why doesn't everyone just use that instead of spending like a lot of money on a calculator?
Do you think that this costs a lot of money?
Oh, did it?
So it's a digital.
All right, I want to show you something. Have I not pulled this up in here in this class?
No.
What?
Never.
Obviously, I'm crazy. Okay, so here we go. I'm clearing stuff out.
So why do you have both? Why not just have one?
Can I have a question?
Yes. Okay, shh.
What is sin and what is
That's
cos?
sine and cosine is what we've graphed back here. It's trig function. I'm gonna give you a big calculator. Do you have your one on your own?
I did.
That's what you own? What kind do you own?
This time.
Use that one. I want to show you something. Okay? So, I still want this answer in terms of pi. Okay? So you've got your calculator on. We're going to plug in just the numbers, not pi. Okay? However you want to do it. You can do 75 times 8 divided by 360. Or you can do 75 divided by 360 times 8. However you choose to do that, go ahead and do it. 75 times 8 divided by 360. I'm plugging it in just like that. I hit enter, I get a decimal. 1.6666666, and then I'll eventually get 7. You have that. I actually want you to do it.
I'll do it.
My pie button. Oh wait.
I don't want you to put it in terms of pi. I don't
Then
want
what
pi
do
to go in there.
What do we put for the thing?
Have you got 1.66666 on your calculator?
No.
I want you to do 75 times 8 divided by 360. Oh. All I want you to do, I want you to get this decimal. And then I want to make sure you know something on your calculator. Okay? Hit the math button. Because I want it to be a fraction. If you hit the math button, the number 1 says FRAC for fraction. You're going to hit enter, and you're going to hit enter again. It's going to give you a fraction.
5/3.
Okay? Does everybody do that?
No way, dude.
Yeah, so then it'd be 5
Does every number have a fraction?
over.
What do you mean?
Like,
Does every number have a fraction? Every rational number can be written as a fraction. Yes.
what's a fraction?
A ratio of 2 integers. This one can be written as a fraction. What cannot be written as a fraction?
Irrational numbers.
Irrational numbers such as
Oh,
pi.
yeah.
That's why you're never going to put pi in there and try to do this, because it won't work. So now you have a fraction that's 5/3. So you have a 5/3 times pi. Okay?
Can you get this on your phone? Is that like a phone app?
No, it's a calculator app. It's not an app, it's a software.
I'm sure you could get this for free.
Generally not.
Find this one.
There is one that you can download as an app. I don't know if it costs money or not. I don't know if it's as high tech.
Is that not a app?
Where did you pull it up?
It's an app.
It's
It's a software.
a software, something I downloaded, but I had to pay for it. So that not everybody can have it. Okay? But I did that. So that's mine. So,
Why do you use that? Why not just use this?
because I want you to see what I'm typing in. It's for a teacher. So that it's there so you can see it. So you can see every single button that I hit.
Whoa.
Okay?
Like search history. Key presses.
Alright. Are we okay? We'll come back to this later. Oh, I'll do it. Okay. Do it in a minute. Next, we're going to talk about the area. So instead of just wanting, 5 pi over 3. Are we finished with that? What? Does it have units?
No.
No. It should be the same unit as your radius. Okay? Should be the same unit as your radius. Everything that we've been talking about the outside edge. The crust of the pizza. Okay? That's what we're talking about. What's the length of that? But what if you wanted the whole pizza pie? What's the area of that piece of pizza or pie, whatever you're having? So what are we going to do? I'm not using this example, but I want to talk about what's the area of a slice of pizza. Or the sector of a circle. A sector is just part of the circle, part of the whole circle, or the area of a circle. Okay? So it's going to be the same general gist. You're going to have a fraction, which is going to be that m degree, the measure, out of 360. But this time, instead of multiplying it times the circumference, what are we going to multiply it by? Yes, the mumble. The area of a circle. What's the area of a circle?
2 times pi.
Pi r squared. You have to know that. Okay? Pi r squared. Okay. So here we go. We have a circle. And I'll give you a radius of 3 centimeters. And I give you an angle, it's not quite 90, it's going to be 80 degrees. And I ask you to find the area of this sector. and shade it lightly. It still went over the 80. Never mind.
You should just shade it everywhere except for the 80.
Well,
Or
yeah. Or I can just write back over it because I was trying to do it lightly. Whatever. Alright, so area of the sector is going to equal the fraction times pi r squared. So if we go ahead and do this problem, what is our fraction? Is it 80 degrees out of 360 degrees times, what's pi r squared? Pi 9, or can I say 9 pi?
You could.
Cumulative property says it doesn't matter the order. Should we reduce? If I want it in terms of pi, should we just reduce? Okay. Now, is it going to work if you plug it in your calculator?
No.
Not if you plug in pi. This one is so nice. Put your calculators down. Think.
Oh, I get it.
Take your zeros out. Will 9 go into 36?
1 over 9. Oh,
Yeah.
4 times.
Oh, so silly.
9 goes into 9 once. 9 goes into 36. How many times? 4. Oh, look, we've got an 8 divided by 4,
Which is 2.
which is simply 2. And we have a pi out there.
Nice.
2 pi. Without having to plug in anything. I know.
Life change.
Life change. And the fact I actually made this problem up, but I used the same numbers I did earlier. Are we done? Should it be 2 pi?
No, it should be 2 pi centimeters.
Yes.
Centimeters
Split.
squared, because it is area. Yes.
1 pi.
Question, do we have homework?
Paxton, I just
Hold your
want
much dip on your chip.
Yeah, man. Too much dip on it.
Alright, so if I give you another one. Actually, I'm actually a lot nicer than what they do in the book.
2 over 1.
It was 2 pi
2 pi.
centimeters squared. I'm trying to think how I can do another one. But in your book, they leave things in terms of pi. So if you're looking at page 225, we're really happy that I'm not doing the one in the book. Letter B. 4,901
Oh, that's just
60th pi. Saxon does not, they're not going, things are coming out evenly.
They
So
are
the
not
problem
messing
I
around.
worked, it worked out much better.
Wait, you say that was B?
Let it be part. No, flip back to 25.
What is
Example. It comes out to 4,901 pi over 60 meters squared.
It's an awful example.
Oh my.
That's the area. And they want it in terms of pi.
That is so mean.
Alright, somebody asked me earlier, will they always give you what you need? Will they always give you a radius? Do they have to always give me a radius?
Because they could give you a diameter.
They could give me a diameter.
Like
Could
that
they?
would give you the radius.
Could they give me the area and ask for the radius?
Yes.
They could, but that'd just be mean. That's a lot of steps.
Oh, because like the radius is like something.
If I give you the area equals 78 meters squared, and I give you the measure of the angle, it was 62 degrees. Can you find the radius?
Yeah.
Yes.
Why wouldn't you be able to do this?
Go.
Okay.
What?
Oh god.
Would you like some help?
Yes.
Okay, I know
No,
that
no.
in science, sometimes the physics that you did, you had to rearrange equations. Okay?
Oh wait, so the area.
So what's the
Wait,
formula?
is it area d pi d? Circumference.
Circumference is pi d.
Area is 2. No,
Just before you say something,
2 times
think,
pi times
am I
one.
going to sound
No,
stupid?
pi times radius squared.
Pi r squared. But in this case, it's the measure over 360 times pi r squared. I'm going to do this 2 different ways. In physics, there's a lot of science. Dr. Hearns always does it this. She rearranges and solves r equals with letters, and then she goes back in and plugs in numbers. I personally never do it that way. but I know that she does because I like numbers, obviously, more than she does. Yes, Jackson.
My question was, why can you plug in 62? Then you kind of just said it. Because yeah, that's how I did it. I did 70.
Oh, I get it. Plug it in.
Okay? Either way, you need to be able to get to R equals. Okay? So I'm going to do it Dr. Hearns' way, the science physics way. Okay? So if I were going to solve for R squared, I need you to do this with me. What was something you would do? What would you do over here to start getting R by itself?
You
Divide by
divide pi.
Divide both sides by pi. A over pi equals multiply by the reciprocal since we got this fraction. Can we multiply by 360 over m times a over pi? These technically both being fractions equals r squared. So close. Then we would take the square root of whatever that is, because my squares over here are going to cancel, and I'm not going to rewrite that all out. Okay? That equals r. So you could just plug in. You plug in a 62 there, put it in the area there. You got two fractions, multiply them together. Square root. It's right here. 360 divided by 62. Or 360 times the area divided by 62 pi.
So you why didn't you plug in 62?
There are two ways. I'm going to solve it both ways. Over here, we're going to do the same thing. Yes.
So is the square root just left there on the left side?
Well, no. If you want a decimal, if we plug in pi, because really you're not going to have a radius that's in terms of pi most of the time. So you plug this in, plug your numbers in, solve, you get a decimal or whatever you get.
So is that when you would put 3.14?
I'm going to put pi. There's a button on your calculator that's pi. Right there. Second. And second. Half.
How much battery life would you say my calculator? It's on a little bit.
That's fine. I don't know. I've got a charger somewhere. All right, so over here, maybe if I'm doing this, I'm going to get a decimal for all of that. Okay? So here we go. I'm going to pull up my calculator again. Put it over here. And I'm going to get 62 pi divided by 360. And I'm going to get a decimal. 0.5410. So I have 78 equals 0.5410, etc., r squared. Something else you need to know on your calculator. Okay, so I've got 78 equals all this decimal. Is 0.5410 really what all that is? No, there's like 6 more decimal places. Okay? Don't clear your calculators. Number one, don't. Just don't. You hit 78 divided by. There's a second answer button that's going to pull the previous answer down there so you don't type all those numbers again. Okay? Hit second, and the answer button is down here right beside enter. You see that?
I never knew that.
Second answer, and it pulls all these decimals into right there so you don't type it again. Don't ever type those numbers again. But I need you to take all of them with you. Okay? So you get, when you divide, you get 444.16, yada, 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 equals r squared. What do I want the square root of? All of that. So I'm going to hit second, square root, second, answer. It's going to pull that whole thing down. And I'm going to hit enter.
My second one doesn't work.
Oh, it better. What? That's second is the up arrow, answer.
Oh, I thought you had to hold it.
No. You just hit it one time. So what is our answer? What is R?
12.0068136.
Yes, and eventually in science and chemistry, you'll talk about sig figs. Significant figures or significant digits. You're given 2, you give 2. Okay? Oh my gosh, we're out of time. This is not good.
Dang.
Sit down, have a seat. Don't move. So, 2 things. When you come back for Thanksgiving, last quarter I gave you a extra credit for the rubbing. This time I'm going to give you an extra credit for a Christmas ornament.
No way.
Okay? I will have a geometry when you get back from Thanksgiving.
Oh my gosh, I get it.
That's
It's like a
Okay.
geometry tree.
I need an ornament no more than like 4 inches by 4 inches, math themed with something written on it. Okay? Not just a shape. That can't be just that simple. You will not get much credit for that.
What do you mean by math?
So could you make
Something
the pie
geometric related.
But we do like a triangle.
Quadratic formula.
Something like that will be okay.
Love you.
All right, they will be due the week after we get back.
I'm gonna write every proof and theorem on the one. I'm going to make